Okay, guys, so we were talking about cluster last time, and we have gone through some of the features of HA, which is high availability. We can also cover, so these are, very important disaster recovery and business continuity features of VMware, and vCenter is famous because of these features of you could disaster recovery, right? So HA high availability we talked about. It's and then DRS we're going to be talking about, and it's all the features. Then EVC and fault tolerance. Hopefully we will be able to reach fault tolerance as well. So I'm going to go ahead and first of all, cluster is a group of hypervisors, right? Where then as a cluster, as a group of hypervisors, um, if any one of the hypervisor goes down, then how to recover it from the disaster and how to make highly available all the virtual machines on top of these hypervisors. So that's where the importance of cluster really comes into action. So wherever medium to large size companies you join, you will be seeing that a cluster is created there. So I'm going to go ahead to the lab and here, disease lab 101, 2 GB, resume it, and then E6i1, which is 10 GB for now. So that's really brutal treatment of this application because it really needs a lot more. And then E6i2, which is, I've increased the RAM to 6 GB because of we have to be able to do the labs properly. And if you have the total of 32 GB RAM or more, a laptop that has that, then you should be able to do that easily as well. And one of the labs, which is vSAN, that's going to be a huge lab. And we're going to actually add one more hypervisor. So we're already like, going or thinking about how much RAM we can use here and there. And then when one more hypervisor comes in, that's going to need its own RAM. So obviously then comes the importance of having a better hardware. Even when you're doing cloud courses, so cloud has to connect sometimes to on-premises environment as well, and that's where then it's okay to have 16 GB RAM laptop, but if you have a good hardware, that goes a long way in your environment. I see so many jobs even now in the market that have a strong hybrid environment where they have some cloud and a lot of on-premises infrastructure. And in order to practice that, you have to have a good laptop with a lot of RAM and CPU, right? Anyway, so I've just powered on all four virtual machines. I'm just going to log in from this Windows machine from where we are remotely connected to the vCenter that is living inside the E6i1 hypervisor. And it has that screen open as well, which we have discussed already. And we have to make sure that admission control is disabled in our environment, just in our environment, not in production. In production environment, it should be enabled. Obviously, it is made for production environment, but it is disabled because it then not lets us use the CPU and RAM of one full hypervisor. We are desperate for as much CPU and RAM we could get for our lab environment, and it's going to actually stop letting us use the CPU and RAM of one full hypervisor. So we can't afford really that in this lab, obviously, just in the lab environment. So that's why we're putting that. Since I recovered that from a frozen state, so it's going to kick me out now. So I'm just going to press this anyway. Here. Oh, maybe I have to convince it that, believe me, I refreshed you. Really? Okay. Oh, it's still working on it. Okay, so, yeah, now it's refreshing. And yeah, so it kicked me out and it's still loading. Well, okay. It's still thinking, so I'm just gonna close that and open it again and go to the recenter URL without UI. And I'm gonna go to this machine as well, which is 10 GB. You know, I should use the full potential of my virtual machine and make it a 16 GB because I have 32 GB full. So I could try to make it a like 16 GB and then inside it should be at least 12. So that's why it's so slow now. The vCenter. To check out a little more, and then I will have to then shut down this machine, increase its RAM to, if I put 16, then 6, 6, 12 plus 16, 28 plus 230. Yeah. I'm still under 32 GB RAM. I will be under. So 2 GB is good for background sources of the laptop as well. And but this is going too slow now, and I need to show a lot of more complicated stuff here. So what I can do is I'll just increase the RAM of my machine. Now, those who have 16 GB RAM maximum in their laptops don't change anything here, but I have to obviously teach and I have to show a lot of stuff. So I need to quickly go for changing the RAM from 10 GB for the ESXi1 only hypervisor from 10 to 16 GB RAM or 14, because later for vSAN lab we will be increasing it again. So I'm shutting down this just to temporarily increase, or yeah,
Sir,
just to increase. Yeah,
if we increase this to 16 for 32 GB RAM, ESXi 3 and 4, do we have 6 or do we have 4?
yeah, 6 6.
Okay. So we have to change something in that too?
Nope, just the 6i1 for the vCenter.
Okay.
Right, so for me, well,
And
it's
do we
okay.
have
Mhm.
Windows machine as 8 GB?
No, 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 no way. It's 2 GB. So we
Oh,
change it on the class third or fourth class.
okay, okay, okay.
So you may shut it down if you have 8 GB. So you can shut it down, change it to 2 GB and power on.
Okay, okay. Even for 32 GB RAM, right?
Yeah, if your laptop has maximum 32, then it's okay to still put it 2 GB because later we're gonna use more RAM for another lab called VSAN.
Okay, okay, sir.
Yeah.
Thank you.
Now this is shutting down, waiting for the services to stop in the background. So yeah, in live labs, wow. Well, there are labs by VMware where they have like you can't if you click something wrong, it's not gonna give you any error. They are just very fixed and strict environment. You can only do one step, second step, third step. Where you have your own lab where any kind of factor can create an error. So that's where we have to, excuse me, see all the factors, obviously.
Hello, sir.
So,
Hello, sir.
oh, hello.
Hello.
Well, you can come near to your mic, right?
Yeah, hello. Can you hear me?
Yeah, now it's better.
Yeah, my hypervisor tree suddenly turned to yellow. The question mark on it. Suddenly, I don't know why.
Okay, can you quickly share your screen? Because yeah, I'm waiting still for my machine to shut down.
Okay.
But you have to be very near to mic.
There's something on top of it that suddenly came up. I don't know why.
So that's the which one is it?
That was
Oh,
ESSI
this one.
3.
That's
Yeah.
showing yellow. And if you go to the summary, okay, so on the right side, you can go a little down on the right side, the summary page. Yeah, this if you scroll down a little just to see what is the error saying. The host currently has no, yeah, that's management network redundancy. We don't really need that. It's just saying that create two, um, two virtual switches instead of one virtual switch for the remote connection. So we don't need that. So this yellow is okay. We can ignore that safely.
Okay. Okay.
Oh, way to go, man. Okay, so I'll share back. Oh, serious. Still thinking. Kidding. Okay, my lab is, if I turn it off instead of shut down, that's not recommended, but um, so it should move somewhere. Oh, starting. Okay, it's not shut. Oh, starting shutdown. Seriously, what's wrong with it? Starting VM kernel shutdown. So it's starting to shut down, but it's kind of stuck here, and I may have to actually turn it off, which is not a very good idea, and hopefully it is okay after that. So I'm just gonna take a snapshot before, which I can't. Seriously, okay. So I was just taking a risk of turning it off. You know what? Maybe I'm putting too much pressure on my RAM, so I'm just gonna suspend temporarily ESXi 3 and 2. So this guy could move, suspend. So I'm relieving some of the RAM and CPU of the device. So, processes coming from this should execute, and whatever RAM it needs should be available. Hopefully it just goes ahead. Oh, I can't do anything. It's all grayed out now. There is. Okay, I'll check a little more and then I have to turn it off. And hopefully it does not get corrupted because of turn off just means pulling the plug. And in fact, I can't even do that. So what I will do is I will turn off the whole, VMware workstation. So this process is stuck somewhere and it's not processing anything. So I'll suspend my Windows machine. You don't have to do that. It's just my machine thing, which is stuck. You should be okay. You should not follow all this. Huh. Yeah, it's not responding at all, and I can't even power off. That's what I was planning to do, power off, like pulling the plug. So I can just close this VMware workstation just on my machine and is busy. Okay, virtual machine is busy. This means the last resort is end task. Oh, that's always not a very good option, but I have, oh, did something move? No, thought something moved here. Nothing. So I'll just go ahead and task this. And task. Okay, everything got. All right, so I'll just turn it on again. Hopefully it has powered off. Are you kidding me? Oh, it's exactly at that step. NTAS did not do anything. Okay, I have to just NTAS other processes of VMware as well. There may be other processes. So first of all, this one, and then I'll check in Task Manager if anything else VMware is here. So in the background, it's still running actually. It just anything VMware or otherwise losses are as we always do. Oh, there you go. VMware authorization and VMware NAT and oh, that's a lot of VMware. Okay, we authorization service gone, NAT service gone, VMware tray. Oh, it's starting again. VMX, seriously? Okay, that's gone. VM and tray. Okay, now we're VMware free. Yes. Anything else VMware? Ah, come on. All right. That solved it. And the machine is shut down. Yes, it is shut down. The E651. That was a troublemaker. I'll just quickly put it to 16 GB here. Press OK, power on. And yeah, power on. While this is powering on, I'll resume at least Windows 10. Now, Windows 1, Windows machine. And I'll make sure that I'm totally connected from Windows to the vCenter. I'm logged in properly, and then I will power on the other two machines. So also, as soon as the E651 hypervisor starts fully, then I need to remotely connect inside and power on the machine. Before powering on, I'm going to increase the RAM of the vCenter virtual machine living inside this E651 as well. So yeah, sometimes we have to T-shoot. And market actually needs troubleshooters where you can resolve issues quickly without disruption or make it fast if it has to be disrupted. So that comes from if you have done once or gone through this, and that comes from if you have done the labs again and again, you will see all kinds of issues. So in the interviews also they ask for what if this happens, then what will you do? What if that happens, then what will you do? If you have done labs 2 or 3 times and resolved issues, you will be able to answer many of the interview questions as well. Okay, so just waiting for this. It has more RAM now, 16 GB. We could also be prepared for somebody else's machine. Like I could remotely connect to one of your machines and then carry on with the rest of the lab if somehow my environment doesn't come back. What else is on here? I think it's not CPU and RAM. Yeah, CPU is just 8 GB out of 31.9. Sorry, CPU is here. The memory is just 8 GB out of 31.9. CPU is nothing. So maybe it shoots up after that. Really. Okay, so I guess if I could connect to someone else's machine or third option is not a very good option. Oh, it's loading, it's moving ahead. Yeah. Okay, let's mute, guys. So while it is loading, our topic was one portion of HA we have already completed, and we were supposed to go for the other portion of availability. So I'll just go ahead with the diagram so we could at least try to know what is going on. So I'll just grab one drawing from the other side and put it here. Okay, so this is our environment, and till now we have gone for, we have talked about HA, high availability in previous class, and HA, we have put that as well in mind that it kicks in when there is loss of hypervisor. Okay, so hypervisor, and what it really does is that it restarts the VMs to on the surviving on the other hypervisors, right? But DRS, it kicks in when there is degradation of performance on a powered on hypervisor. So hypervisor crashing has nothing to do with DRS, and DRS can't do anything if the hypervisor actually crashes. But if the hypervisor is powered, it stays powered on and it's just too slow, or the CPU and RAM is not much available for the virtual machines, then DRS kicks in, and DRS can actually analyze that. Suppose ESXi3 has more CPU and RAM available, while ESXi2 has less CPU and RAM available. So it simply analyzes that and then decides for itself, if we configure it that way, that it will simply vMotion the virtual machine from a slow hypervisor to a fast hypervisor. And if the users are connected on this virtual machine that is being vMotioned, so the users won't even know that underlying their virtual machine that they're connected to has been moved to another hypervisor or another physical server. So that's exactly then what will happen for in case of DRS. So it kicks in when the hypervisors are on, but they are slow. And then comes FT, and this is it kicks in when an active VM, or the underlying hypervisor of the active VM crashes. The active VM services failover instantaneously to the passive/standby VM right away. So so this means that you have to have two virtual machines for it to basically work. Here in HA, it's just one virtual machine. If the hypervisor goes down, the virtual machine also shuts down effectively right away as well. it's not available anymore, but it restarts instantaneously on the other hypervisors. And DRS, it can just vMotion a powered on virtual machine from slow hypervisor to a fast hypervisor. It can do it automatically as well. Or it can give a recommendation to you and you can do it manually yourself. The vMotion that we did the last class. And fault tolerance is that you must have two virtual machines, one in one hypervisor and other on the other hypervisor. So the active one, if it goes down, its services are failed over in milliseconds to the standby or passive VM on the other hypervisor, right? So that's how these three very important, services work. And I'm just going to go back and check it out. So we're closer. Oh, now it's moving. Maybe it knew that I'm about to look and it started moving. You know, the underlying, oh, there you go. Okay, so the second hypervisor is done. Like the E6i1 is done, and that hypervisor actually has our vCenter, which is shut down right now. But I'm going to increase the RAMs and expect it to start fast. So E6i1, yes, that's what I need to remotely connect to and quickly start the vCenter. But before that, increase the RAM and then start it. Refresh your browser, it says. I'll click refresh here. And then, yeah, advanced and proceed. And then root password is class passwords. So obviously 36.123 without shift 123. I'm going to go to virtual machines. It's saying that I think the storage for it is not available. Storage is coming from 01 to E6i1, right? So I have to go to storage because if it says like this, then there might be a storage issue. And if I try to go here to adapters, rescan and refresh, devices. If I say it's 3 devices, yeah, we're good. It's supposed to be good. So how come it shows just 2 hypervisors? That's not good. Not working. If I go, okay, and then storage again. Devices, refresh, rescan, refresh. Wow, sometimes we have to T-shoot. So it's just looking for devices, right? If I just check here, yeah, the 3 MSFT are showing. Yeah, this is always the case, the yellow one, it's okay. And if I go to rescan here for actually iSCSI software adapter, which is this, I select that, rescan, and then once rescan is done, refresh. So data stores. Are you kidding me? Where's the third one? Did I delete that? Oh, well, the data store is missing, right? But the LUNs are there because the 3 LUNs are there, right? So we're good. But when it comes to data stores, maybe I created that virtual machine on the first data store, LUN 1, right? So if LUN 1 is gone, then my full virtual machine could be gone. Well, so I'm just gonna check out from this virtual machine. That's where the 3 disks are, right? Although the 3 LUNs are showing, so I should be okay. So if I go to file and storage services here and go to iSCSI services here, that's where we are giving the disks from over the network, the LUNs. And all 3 are saying connected on 1, on 2, on 3. So from the target side, it is okay. From the initiator side, it seems like there's an issue. And I'm going to remotely just go back into this E6i1. And this virtual machine, if I click that, it doesn't show power on, power off. So there's something seriously wrong here. Oh man, I don't want to reinstall the whole thing. No. See how long the no was. It's that bad. Oh, serious? Data store browser. Where's the first one? Not this. This is the local one. W1 DS3 1. I don't remember destroying it or deleting it. Okay, I'll just start these guys. I don't starting these guys or these guys being shut down has nothing to do with LANs. So yeah, they're resumed now. And the vCenter, like they're being started has nothing to do with not auto refresh. Oh, auto refresh. I'll just put it to 15 seconds. Just keep refreshing. Thank you. Okay, that's not good, guys. I may have to reinstall the whole vCenter again. That is VMHBA65. Refresh. Really. So what's your suggestion? I'll start installation and let's meet some other day, or I don't know. What do you want? Refresh, scan. Which one is not responding? Scan. 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 Did that got could not fill up any errors there? No. Really? What else? So it's that one data store. Actually, long as there, just the data store is missing. Like the one is here. Okay, that's I could also see that if the one is fully used, if it tries to show me. If I go back here, my energy capacity, but it doesn't show that how much of it is being used. It's not still showing that how much of it is down. Does not say any of the ones are actually missing for storage. 599, 158, MSFT. Oh man, don't make me create the data store again and then reinstall the. Oh, there you go. The first one all of a sudden is there. I think so. I had to refresh all the ones one by one, like this, and rescan like this, rescan and this, rescan. That really, you know, pushed the signals and sent a refresh signal to this. Okay, anyway, the long as here, so the virtual machine should be here as well. All right, virtual machine's here. Yay! Okay, so yeah, that was a victory. And then edit. So guys, yeah, even in production environment, you may have to do this kind of troubleshooting where the SAN LUNs are not detecting, and you have to go to storage and then even click one LUN and refresh, rescan, actually not refresh, rescan, and then second LUN rescan. So it can happen in your production environments as well. But anyway, 8 GB here. So I have 16 GB now, so I could give it extra 4 GB, right? 12 GB. Why not 14? Because for vSAN lab, we have to still make it less. And that's gonna then take time. So I'm just making it 12 GB and powering on. Finally, like that. But underlying data store may not show up. This happened to me the first time now. And thank God T-Shoot worked. Photon version 3.0. Now it's gonna start and then we're gonna send it to refresh. Keep on refreshing here. Yeah, it's now automatically trying to refresh after some time. Yeah, it is. So while this is going on, and hopefully we're going to be logged in, I'm going to be logged into vCenter. So what we can discuss here is the DRS side of things. So, and while the availability, we're going to still discuss another section of that. That would be not much, but we're going to be now going for DRS, which is Distributed Resource Scheduler. So what it exactly does is that DRS automatically analyzes every 5 minutes the CPU and RAM of all hypervisors in the cluster, and if it sees that a virtual machine, okay, it analyzes our cluster and the need of VMs and the need of CPU and RAM for VMs. So it goes for how much capacity hypervisors can offer and how much CPU and RAM is needed by virtual machines. So the one that is offering and the one that is requiring CPU and RAM, both sides, it keeps analyzing analyzing every 5 minutes, right? So it has a latest report of, oh, this virtual machine, the critical one, actually needed a few minutes before it needed just it was on 80 GB 80% consumption of CPU and 80% consumption of RAM, and now it's on 95%. So then it simply decides automatically that which hypervisor is the best option or has the most available CPU and RAM, and then DRS simply automatically moves the virtual machine from the slow hypervisor to the high performing hypervisor in terms of CPU and RAM. So it does that automatically. We can configure it to only recommend which VM needs to migrate to which better performing hypervisor. So we can configure it to only recommend which VM needs to migrate, or we can put it to, there's that, we're going to be configuring that fully automated and fully aggressive. It's a feature there, fully aggressive. So what is fully automated and fully aggressive? So fully aggressive has 5 levels actually. So fully aggressive have 5 levels. The highest level offers the slightest change of performance migration. Oh, what does that mean? Like if the virtual machine, so if there's a virtual machine here, and if it is fully automated and fully aggressive, so here it keeps on analyzing every 5 minutes, right? So it analyzes that this ESXi2 is, on 90% of CPU and RAM usage, while this ESXi3 hypervisor is on 88% of CPU and RAM utilization. So it's only 2% of difference, or maybe even 1% of difference. So when it comes to fully automated and fully aggressive mode, I'm going to show you where they are. Then even if there's a guarantee of slight improvement of performance, it simply moves the virtual machine to that hypervisor, right, which is offering slightly better performance, just slightly better. in this case, whichever hypervisor has the best performance status, like whichever hypervisor has the most CPU and RAM available, it's going to keep on moving that hypervisor. Suppose you have 200 hypervisors, right? So 200, but one cluster can hold 64 maximum hypervisors, 64 maximum hypervisors, right? So within 64 hypervisors, whichever hypervisor is offering the slightly more better performance, it's going to move right away the virtual machine to there. So this means that this virtual machine will always have the best performance available for the users. Maybe thousands of users are connected to this virtual machine, or hundreds of users are connected to this virtual machine, but it will have the best performance available among the 64 hypervisors within one cluster, right? So DRS just tries to. And then there are 4 other levels. This is the highest level where fully aggressive and fully automated. If it is on both of them, then it's just, so you can just put the fully aggressive to 4th level, which is, if there's a 20% difference between the performance, and then it comes down to 3rd level, which is 30% or 35% performance difference, then only it will move. And then it comes down to 2nd level and 1st level. 1st level of this fully aggressive is that if your current hypervisor is about to shut down, only then it will move, otherwise it will not move. And the best 5th level is if there's a slight chance of better performance, it's going to move right away, right? So maybe within 1 hour, your virtual machine would have migrated to or changed 50 hypervisors by then, within just 1 hour. It could happen as well if there's a performance variation. But moving the virtual machine from hypervisor to hypervisor does not really affect the performance of the end users, which are connected to that virtual machine. So if I go back here, no healthy upstream, okay. / maybe the background services are still starting, but I'll just push it. Try to ask it to just go ahead and load. Put the UI, small UI there, just to trigger some service to get started. Seems like something's happening. And well, okay. While this is going on, and I could get hypnotized because of this, round, right? So I don't want to get hypnotized. So I'm just going to go back here. So fully aggressive is that, right? So if there's a better performance, shall I move if there's a better performance or not? So that would be the functionality of the fully aggressive. While the functionality of the fully automated is, there are 3 levels for that. Fully automated has 3 levels and offer 2 functionalities. What are those? One is that, to migrate a VM to a better performing hypervisor or host, right? And the second functionality is if the VM is starting from a restart or shutdown, maybe you shut down and you're starting now, or it is starting from a restart. You just restarted the machine, right? So when it's about to start from either a restart or a shutdown, it will analyze that which hypervisor is best suited to start this VM. And that is called VM placement. So what is VM placement? That it's about to start. So why don't I start it? DRS thinks that, why don't I start it on the best suitable virtual machine? So suppose the virtual machine was working out of this, and you restarted from E6i2. But it's about to start now after a restart, or maybe it was shut down and you're about to start now. So the DRS automatically thinks that, hey, in terms of CPU and RAM, it was working on E6i2, but now DRS thinks that E6i3 can offer more CPU and RAM to this. So it basically starts it right away on that best suited hypervisor, whichever is offering more CPU and RAM. So that is called VM placement. So DRS does two things. If it is already powered on, but the underlying CPU RAM is not enough, so it migrates a virtual machine. So yeah, that's vMotion, right? That's the first thing DRS does. And the second thing DRS does is machine placement, which is that if it is starting from a restart or shut down, so it places the virtual machine on the best suited hypervisor, whichever is offering more CPU and RAM. Suppose it was working from here and its same is the best. So it analyzes, it has a report of all other available hypervisors and still sees that, oh, the more CPU and RAM is actually being offered by the same hypervisor where it was. So it will just start it from here. Or suppose we have 200 hypervisors or 64 hypervisors in that one cluster, and it sees that 23rd hypervisor here actually is offering the best CPU and RAM. So it just starts from 2 to 23rd hypervisor there, right? So that's called machine placement. And the other one is migration. If it is just powered on and it needs more performance, it just migrates. If it's about to start, it places the virtual machine on the best suited hypervisor in terms of CPU and RAM, right? So if we go back, oh, we're here. So finally, the vCenter is showing, and username, password has to be correct as well. So let me see. Camera, let me see, shift 1, 2, 3 without shift 1, 2, 3. And I pressed enter as well. Really? Click administrator add vSphere dot local. I did shut down that authorization service. Okay, it might want us to just simply process this way. So I would want to see the services if the authorization service is started for VMware. And that's for VMware Workstation, not for this. All right, so finally we're inside. Woo-hoo, yay! All right, so once we enter the vCenter, all right, now our Tor cluster is showing those insufficient resources error, while we have given E6i2 6 GB, E6i3 6 GB, and now E6i1 has 16 GB. And this, well, they should detect soon that they have enough resources. Also, I would want to go for Tor cluster and configure and availability, because I want to check out this edit, and I want to go to admission control. It should be disabled. Yep, it is disabled. So that's what I want for now for the training environment only. It still says insufficient resources. The E6i2, if I go to summary and then E6i2, so the vSphere HA host status shows this. vSphere HA host status. That's Now we just started now, so maybe this it will recover from that error. We'll check it out soon, because it's always constantly sending agent communications between the hypervisors and the cluster, and it could automatically recover from this after some time. If not, then we're going to check it out what happened. So what we were discussing last time was that I'm on a Tor cluster level, and then there's a configure here, and then there is vSphere availability here. Then we will be discussing DRS as well. But vSphere availability, we were on, and they are both powered on right now. So we have discussed last time, if I go to edit here, and then we discussed all this APD, PDL, VM monitoring, host isolation. So in on 15th class quiz, there will be questions coming from all these. And then there is admission control here. We talked about that, heartbeat depth stores as well, and then advanced options. So I'm just going to cancel out here because we've discussed that, but we will go for the second one, which is proactive HA is turned on. So I'm just going to click edit here for proactive HA. And this is not a lot here. There's not a lot here, but it says here you can configure how proactive HA, proactive high availability response, when a provider has notified its health degradation to vCenter. So a provider has notified, like suppose there's a monitoring tool that has actually sent that, hey, this hypervisor is about to see bad degradation, a lot of degradation of performance, right? So you're getting those health indicators, or monitoring tools are sending that much information there. So including a partial failure of that host. So there's a provider that is sending continuously health information that there could be a partial failure of the host. In the event of a partial failure, vCenter server can proactively, even before the partial failure has occurred, the vCenter can proactively migrate the hosts running VMs to a healthier host. So that's a good thing. Till now, we were talking about that if a disaster happens, in response to that disaster, that has already happened, then HA kicks in. If degradation happens, so then DRS kicks in if disaster strikes to the active VM or the underlying hypervisor, then FT kicks in, fault tolerance, right? But it says here that it's going to be proactive, right? So it's going to be server can proactively migrate the hosts running VMs to a healthier host. So that is also possible. Proactively migrate the hosts running. So this means that the alerts are given and virtual machines are migrated away from the host before it actually crashes or partially goes down. Okay, so some services are partially degraded. In that case, already it can do that. So it's so set on manual, but if we go for automated here, virtual machines will be migrated to healthy hosts and degraded hosts will be entered into quarantine or maintenance mode, depending on the configured proactive HA automation level. So maintenance mode, so it just says that if you put it on automated, so the virtual machines will be put to either a maintenance mode or quarantine mode, the hypervisor. So suppose this hypervisor 3 is about to partially fail. So DRS will simply migrate the virtual machines before the partial failure actually occurs. And once it does occur, so the hypervisor will be automatically sent to the maintenance mode. Maintenance mode means that, well, maybe there's a maintenance going on, so no virtual machine can actually run on it. Quarantine also is a total isolation of that that hypervisor. So in case of quarantine, also no virtual machines can stay on top of that hypervisor. So that is automated. If you put it on automated, and then do you want to put it on quarantine mode, mixed mode, where maintenance and quarantine, some features of maintenance and some features of quarantine would be implemented, or just the quarantine mode. So whichever you want. Right now it's on quarantine mode, where it's not, it's just isolated. As long as a failure or partial failure reports are coming from it. And as soon as it recovers, it's going to be put out of quarantine to a normal mode. So that's just the setting that you can do if you want. Then comes the providers, and enable providers and select rows to view and edit the failure conditions supported by the event provider. So these are just the providers or third-party services that you can add, that if failure occurs, then how do we respond? You just have to purchase a expensive license for some kind of third-party recovery features of or maintenance software offering those features to the hypervisor. So if you have some third-party software providers, then you can add here and then configure them. But this proactive HA part of that just offers that, hey, if you have a very good monitoring tool, VMware offers their own monitoring tool as well, which is very, very good, but also very expensive license application called vRealize. So VMware has an application called vRealize, and that application monitors proactively, and reports coming from that proactive monitoring tool called vRealize will let them decide if they should move the virtual machines from that hypervisor that is about to go down partially. So I made that change of automated and then click save. Then I'm going to go for the DRS here. And the DRS, as I was talking about, there's a fully automated. It's already on fully automated, but I'm just going to go to edit here just to confirm, go through the features of this one. Okay, so yeah, so DRS is distributed resource scheduler. So it has automation, first of all, then additional options and power management and advanced options. So automation level, fully automated, as I was talking about in the slide as well, partially automated and manual. So if we go to manual first, so what does it do? And the two things, always remember, DRS does two things. One is VM placement and other is vMotion. DRS does two things. One is VM placement and the other is vMotion, and we just talked about the two of them. So the manual, if you put the automation level to manual, so what happens is DRS generates both power on placement. That VM placement is called power on placement. So when the machine is started from a restart or a shutdown, right? So that is power on placement. So do you want DRS to only give you placement recommendations as well as migration recommendations? So we are telling DRS, if we put it to manual, that do not migrate virtual machines, do not migrate virtual machines, and do not place virtual machines on better hypervisors. Just give me recommendations, but don't do it yourself, DRS. So that's, if you put it in manual, it's going to give recommendations only to you as an administrator, that, hey, I recommend that the machine is starting, so put it on this hypervisor and that hypervisor, right? And migrate this virtual machine to that. So it doesn't do anything, it just gives recommendations. But if you go for partially automated, so what it does is DRS automatically places virtual machines onto hosts at VM power on. So the VM placement part of DRS is done by DRS automatically, but still it will give migration recommendations only. It will not do the migration itself, right? So placement is automated, but migration is not automated, it's manual. And when you put it to fully automated here, then both DRS automatically places virtual machines onto hosts at VM power on, and virtual machines are automatically migrated from one host to another as well. So now no more recommendations. You put it on fully automated, then DRS automatically places a virtual machine on the better suited hypervisor and automatically migrates as well the virtual machine from low performing hypervisor to a faster performing hypervisor. So it's on fully automated right now. And then there is migration threshold, and that's where we were talking about aggressive. Fully aggressive and fully automated is the combination there that makes it totally automated, and you can just leave this and do something else. Maybe you're resolving some of the ticket and you want automatically DRS to handle your virtual machine performance wise. Okay, so if I go to fully aggressive mode, right? Aggressive. So more frequent V motions, as we were discussing in the slide as well. If you put it to this mode, so the DRS provides recommendations when workloads are even slightly imbalanced and marginal improvement may be realized. For dynamic workloads, this may generate frequent V motion recommendations. So now migration threshold that, hey, we are ready to migrate, go ahead. And the automation level simply migrates, right? So threshold gives recommendation, and automation level feature acts upon that recommendation right away. So if you put the recommendation level to aggressive mode, so this DRS feature will check that, oh, E6i3 is slightly faster than E6i2, and it gives a recommendation. If this is also on fully automated, so it will simply do it. It will simply migrate the virtual machine. So it depends on then which level you want. Then it says DRS provides recommendations when workloads are fairly imbalanced. So it did not give any percentage to that. Here it says that slightly imbalanced, even small. So I could just explain it in like, suppose one hypervisor is 90% CPU and RAM used, and the other hypervisor is 88% or 87%. So that's just slightly different. When you go to this, so the difference of, we can say 15% to 20% difference is there, that CPU and RAM is more available, and it's 15% different, than it goes. But the numbering has to be confirmed from more digging down into the documentation, but the automatic algorithm happens in the background. And moderately, when it goes to this, moderately imbalanced, which means that at least 30%, 40% difference is there, then it will move. And then it goes down to second level, extremely imbalanced. So maybe there is 70% of difference of performance, and then only it will move. And then it goes down to, if this hypervisor is about to put into maintenance mode, you have to move the machines now, because the hypervisor is not going to be functioning. It's going to be in maintenance mode. So then you have to move. Only then it will move if you put it to that. So what I'm going to do now is we're going to do a test here, and that is we put it to fully aggressive mode, which means that in even a slight hint of better performance, and it will move the machines to the other hypervisor. So fully automated and fully aggressive mode, I've put that on fully automated and fully aggressive mode. So what I'm intending to do is that I'm going to put all these virtual machines on any one hypervisor and power them on, right? So this functionality of DRS, fully automated and fully aggressive, will check that. And fully aggressive, the migration threshold will check that, hey, the other hypervisor, which is empty, is offering more CPU and RAM, and it's going to recommend right away that, hey, automation level, you can migrate some of the machines to the other hypervisor. And it's going to keep on, migration threshold will keep on checking until it says that, okay, you have migrated 3 machines or 2 machines already. Now it's okay, it's balanced. So don't move more, right? So what we're going to do now is I'm just going to power on all 5 virtual machines here, and or whatever your number is, maybe 3 you have, maybe 4 you have, or 5 or 6 you have. So power on all and move them to any one hypervisor. So as soon as they power on those machines, DRS will also start performing placement, right? Which is that which machine should be on. So, but once they're all powered on, I intend to move all the machines to any one hypervisor, right? Then after that, the magic will happen, and you will see that although we have moved all the machines to one hypervisor, in the background, then DRS kicked in, and it moved some of the machines again back to the other hypervisor without our manual intervention. So I'm just going to press OK after putting this to aggressive mode and fully automated mode, and I'm just going to press OK. And I hope these errors don't interfere with our lab. So I'm just going to try to power on. Now, all virtual machines I've mentioned as well that put them to 1 GB RAM. So because we have very less RAM, yeah, 1 GB RAM. So I'm just going to power on this machine. And I'm also supposed to notice that it's on E6i2 right now. VM01 is E6i2. But I'm just going to keep on powering on. Then maybe I'll use 4 virtual machines here because we have a total of 6 GB RAM only here. So we can use in this experiment 4 virtual machines. We can power on 4 virtual machines instead of 5. Or virtual machine. No host is compatible with the virtual. Ouch. That's not a good news. Okay, you know what? Let me just go to the E6i2 because they did not let us power on. And now it could be that it was available the license was available for 60 days. So hopefully 60 days have not passed. So I'm just going to go for E6i2 and configure. I think licenses are there in configure licensing. So E6i2 configure licensing, and GPUs. Oh, it's 10 October. So yeah, it's not expired actually. So we're good. Yeah, 10 October, right? So I'm gonna check for this as well. This is also 10 October, so we're good. It hasn't expired yet. So why this error? Now there's another way to check it out as well, and that is I'm going to go to this virtual machine area, virtual machines, and so VCLS are the VMs that actually keeps the cluster services up and running. And it says vSphere cluster VM is required to maintain the health of vSphere cluster services. Power state and resource of this VM is managed by a vSphere cluster services. So vSphere cluster services, whenever it wants it to power on, it will power on, and whenever it wants it to shut down, it will shut down. So that much is okay. I'm just going to go back to this hosts and clusters area. And when I was trying to power on the virtual machine, it actually did not power on. So there may be something wrong. Now, what we can do is, if I right click here and go to, yeah, I would want to restart because I just resumed it from frozen state. So it's better to restart. But there's another thing called connection, and there we can disconnect. But if you disconnect, then you will have to add the hypervisor again to the vCenter like in earlier classes, the second and third class. So what we can do is we can just reboot this hypervisor. So this is ESXi2 that I'm about to reboot. ESXi2 power reboot. Source is not in maintenance mode. Rebooting a host that is not in maintenance mode does not safely shut down running virtual machines on the host. Yep, you're right. But the machines are not powered on, so I'm okay. Enter reason to proceed. testing, whatever you can type there. It will be done in the logs. So I've restarted 692. I'll go for, so if you don't see those red errors, then you don't need to really do that if anybody's following or when you follow later. So I'm gonna check if, yeah, it's restarting. This is site 2. And yeah, this site 3 is also restarting. Once they're restarted, though, then the agents inside of hypervisors should communicate with the agents in vCenter and exchange the status of services. And it should be okay. It's nearly started. Response. Okay, there we are. Okay, so the virtual machines are nearly, oh, the hypervisors are nearly started. And the status is kind of okay. So even if it goes to yellow, then we will have to just check that what exactly is the message in yellow saying, if it is yellow. Otherwise, if it is red, obviously we have to check exactly what is the message being, what is the error. Okay, so VCLS or the cluster services related virtual machines are starting. And so if the hypervisor in a lab environment have not been restarted for long, then it does require restart after some time. So they seem like okay now. So what I was doing was to test the DRS automation. If I go back here to edit and fully automated and fully aggressive mode, we were supposed to test that. So I'm gonna try to power on the machine now. 4 virtual machines I'm going to power on and then put them all to any one hypervisor. And let's see if the virtual machine is powering on. Yep, it is powering on now. I'll go for the second machine and power it on as well. So I'll go for 4 virtual machines that I'm powering on. Obviously, it's going to put some pressure on the already limited RAM of the hypervisors, but I will try to push them. So 21 hypervisors. So I'm just going to check that how many virtual machines are on which hypervisor, or which hypervisor has the most virtual machines. So if I go to VM01, it's on E6i2. If I go to VM02, it's on E6i3. If I go to VM03, it's on E6i2. If I go to VM04, it's on E6i3. So 2 machines are on 2 and 2 machines are on 3. So I'll just move them all to E6i3. So I think 1 is on 2, VM01 is on 2. Yep, is on 2. So I'm going to move this to E6i3 as well. And then I think VM03 is also on 2. Let me check. Yeah, 1 and 3 are on E6i2, while VM02 and VM04 are on ESXi3. So I'm going to move VM01 and 2 also, VM01 and 3 also to ESXi3. So all 4 machines will be on ESXi3. And then I'm going to leave it at that. And I expect that DRS, after a few moments or after some time, it should automatically migrate the virtual machines back to other hypervisors to balance out this CPU and RAM usage, right? So just checking again, VM02 should be on E6i3, yes, and VM04 should be on E6i3, yes. So I'll just move the VM01 and 3 to ESXi3 as well to put pressure on DRS. So I'm just going to migrate VM01. Obviously, our vMotion service should be intact. I'll just move it to ESXi3. It should be compatibility check, should be green. Next, yes, the networks are okay. Next, and schedule with high priority. Yes, next, and finish. So move the VM01 from 2 to 3, right? So this should change for VM01 from 2 to 3. I'm just gonna do that for VM03 quickly as well. So I'm just gonna go to VM03 and right-click it and migrate. Next, ESXi3, next, next, finish. Finish. So all should be 3 now. At least VM01 should be 3 as well, ESXi3. The one is on side 3 as well. And VM02 and 4 we already confirmed are 3, and now all VM03 is also on ESXi3. So we're going to leave it as is, and we'll check after some time that so they should be all on 3, unless they have moved it right away. 1 is on 3, 2 is on 2. Seriously. So DRS acted right away. It worked. We all confirmed, I confirmed like 2 or 3 times that VM02 was on ESXi3. Now it is on 2. So DRS moved it. VM03, I moved to 3. Yes, it is on 3. VM04 was on 3. It's on 2 now. Seriously. So while I was moving the other VM01 and 3 to ESXi3, VM02 and 4 were being moved by DRS after a few seconds to ESXi2. So these VM02 and 4, we confirmed they were on ESXi3, but now without us moving these 2 guys away from ESXi3, DRS actually moved them to ESXi2 from 3. So DRS worked right away, but maybe there is where are the recommendations? We can just check out from there as well. So if I go to monitor, so first I'm going to go to cluster. First I go to cluster and then go to monitor. And then I go to history, vSphere DRS and history. So these are all the placements that DRS did at what time, and also the migrations DRS did at what time. So right now it's 7:21. So at 7:20 and 7:19, 1 and 2 minutes before, it moved VM02 to E6I2 and VM04 to E6I2. But it also moved VM03 to E6I2. Seriously? Okay. VM03 is, if I go to summary, it also moved it to 2. Why? Because these 3 are empty machines. 2, 3, 4 are empty machines with no operating system inside, while VM01 actually has an operating system inside. So in fact, yeah, it is on 3. VM01 is on 3. It is a bit more heavy. VM02 is on 2, VM03 is on 2, and VM04 is on 2. So that's DRS's way of balancing it, but it will keep on also checking if the other hypervisor is now offering more CPU and RAM, and it's gonna move that again. But yes, whatever we did, we saw that in the background, DRS was doing its own maintenance, right? By moving the machines automatically without us doing that. So that's a pretty good example of DRS, that it works like a magic. So I'm just going to go to the cluster level and then go to configure and then DRS. That's where we were, and add it. So yeah, fully automated, fully aggressive. If you're doing something else, maybe you're in office, you want to go to a party, and somebody has to stay back and nobody's there, so you can just put it on fully automated and fully aggressive, and it will just keep moving the virtual machines of the end users to the best possible, best performing hypervisor again and again, right? But obviously you're the administrator, so you have to still keep an eye on everything. They are still machines. They can go wrong as well. All right, so if we go to predictive DRS, and that is if in addition to real-time metrics, DRS will respond to forecasted metrics as well. So there's a forecast of degradation of performance, which hasn't happened yet, but will be happening because of the monitoring alerts that are coming. Suppose there's one virtual machine, the monitoring alert is saying it is using 70% of CPU and RAM, and then after 5 minutes, it says it's using 77% of CPU and RAM, and then after 5 minutes, it's using 83% of CPU and RAM. So just by seeing the forecast or trend of a virtual machine about to go degraded performance, so it can also move a forecasted machine from a low performing hypervisor to a better performing hypervisor if you enable that. So then there is virtual machine automation, and override for individual virtual machines can be set from the VM override page. So override means that whatever HA policies and DRS policies you have implemented, those policies will implement obviously on all virtual machines that are available. But if you want certain virtual machine to not follow the HA and DRS policies, then that certain virtual machines can be overridden. So we can override. So once this is all done, I'm just going to show you, or maybe we are still, since we are seeing that override now, so why don't I show you now? I'm just going to press OK here. So I'm in tour cluster and in configure. If I go further down here, so there is VM overrides here. If I click the VM overrides and then click add here. So what it offers is that, first of all, it says that, hey, which virtual machine you want DRS and HA to not touch. You don't want a certain virtual machine be affected by DRS and HA policies. So suppose I go for virtual machine 2 and then next. So then it says that what do you want to override on DRS level and what do you want to override on HA level. So if I click override here, so for all the virtual machines, the default is fully automated. But maybe for this one virtual machine, I'll go for, hey, just give me recommendations that what placement, which hypervisor to put it on if it is started, and which hypervisor to put it on if it needs to be migrated, right? So DRS automation override. Now DRS will not, the DRS settings on the, the level of the vCenter will not affect this particular machine, virtual machine that we selected in the previous page. And this goes the same for what you want to implement on that. So you don't want, you want to override this, so that's a policy of VM restart priority. But for this virtual machine, maybe it's very, it's not a critical virtual machine. So maybe you can go for lowest tier that don't restart, or restart this virtual machine the last when disaster strikes on hypervisor. Restart all other virtual machines first, and then restart this virtual machine, because its priority for restart is lowest, and the priority for restart for other virtual machines is highest. So you can override any of those APD, PDL features that we discussed and VM monitoring features that we discussed in previous class. So that is override. I'm just going to cancel out from here, but this is the override that it was talking about. I'm going to go to DRS again and edit. So that's it was saying that go for override of these conditions. Otherwise, machine automation is just automatically implement whatever features you're chosen up of there. So automation would be this. Additional options if you go for, so VM distribution. This is also an interesting one, that enforce a more even distribution of virtual machines across hosts in the cluster for availability. May see a degradation of DRS when utilizing this setting. So this is about virtual machines being evenly distributed. So if so about this, if it has, suppose you have virtual machines here, and you have several virtual machines here, and because of the DRS, suppose this hypervisor has a lot of CPU and RAM, and the other hypervisor has comparatively lesser amount of CPU and RAM. Maybe this is older hypervisor, this is much newer hypervisor, or its CPU and RAM has been upgraded. So the hypervisor, then DRS would think that, hey, since it's offering a lot of RAM, so it might put a lot of virtual machines here. So suppose you have here a total of 10 virtual machines here, and maybe a total of it had 10 virtual machines here as well. But the DRS thinks that, hey, this one is offering more CPU and RAM and this one is less, so why don't I go for making it 18 virtual machines here and 2 virtual machines here because of less CPU and RAM here. But then that option that we just talked about, so this option says enforce a more even distribution of virtual machines across hosts in the cluster for availability. So degradation might happen, obviously, but the thing is that if there's an even distribution, so there are first we put 18 here and 2 here, so that's not an even distribution. Suppose there are 18 here because of the best performance, but this hypervisor actually crashes, so it's taking down 18 virtual machines, majority of the virtual machines with it. They will have to restart because HA will kick in, but that's a disruption, right, for a large amount of users. So that's why if there was or there is an even distribution, that would be, as we were seeing before, that 10 here and 10 here. So if this hypervisor crashes, it's just taking down or restarting, disrupting the process of 10 virtual machines while the other 10 are still intact and the users are still working, right? So even distribution. But again, if the CPU and RAM is more available here and in higher capacity, it has been upgraded here. So, and if you put it on even distribution, so obviously with lower CPU and RAM, and you have to evenly distribute, the virtual machines will see degradation here. So it's up to you how you want to go for it, that you would put it on even distribution just to be ready for any crash. That crash might happen next hour, or it could happen next year. We don't know, but throughout the year, you might see degradation of performance for those virtual machines. So it's up to you what you really want it to do. Just follow uneven distribution, or and risk whenever the crash happens. Maybe it happens after 2 years. Maybe it happens now. We don't know, right? So it's up to you. So enforce even migration. There is this a CPU overcommitment, and that is if you have more CPU, like there are virtual machines that are asking for more CPU, and you don't have physically that kind of CPU, then how do you want the ratio to be 1 to 1 or 2 to 1, one vCPU to one physical CPU, or two vCPUs to one physical CPU? So it's up to you how you want to distribute. If during peak hours it's doing overcommitment and it needs really more CPU, then. And then there is scalable shares. Enable scalable shares for the resource pools on this cluster, which means that suppose you do that. So scalable shares, what is a share? Share means that, hey, hypervisor, please pay attention to us, the machines in the resource pool, or a group of virtual machines, please, in the VApp, please pay attention to us because our shares are more. And suppose there are more 4 VApps here. In each VApp, there are 555 virtual machines, but the one VApp has more shares. So hypervisor will listen to that VApp first, which has more shares, and that VApp least, which has the least amount of shares. So scalable shares just means that increase the shares of whichever hypervisor, whichever group of virtual machines are critical, most critical, increase their shares. So shares just mean priority. So those machines will be listened to first in terms of how much CPU and RAM you need. They need. Power management is another feature, interesting feature that really saves hydro bill. So electricity bill you want to save for the virtual machines, then the power management is the feature. And what really happens there is that suppose you have a lot of hypervisors here, long list of, suppose you have 200 hypervisors here, lots of hypervisors. And obviously they are eating up your electricity because the hypervisors are hosting virtual machines. Each hypervisor may have 10 to 20 virtual machines there, or 5 up to 20 virtual machines there, according to the whatever hardware they have and whatever CPU and RAM and storage and networking virtual machines actually need. So suppose you have a lot of hypervisors here, but now you have 200 suppose hypervisors, and they are all eating up a lot of electricity, and per month electricity bill is a lot coming to the company, and the company tells you, hey, VMware administrator, can you reduce the bill of electricity coming from the data center where we have 200 hypervisors? And then you say that, okay, I have a feature in DRS that is called power management. And in that feature, what really happens is that what happens is if you enable power management, so I'll just, so suppose we enable power management and we put it to automatic and fully aggressive. So vCenter server will apply power on recommendations produced to meet vSphere HA requirements or user specified capacity requirements. Power on recommendations will also be applied if host resource utilization becomes higher than the target utilization range. Okay, power off recommendations will be applied if host resource utilization becomes lower than the target utilization range. So what it means in English is that uh, DRS will calculate how much of the hypervisor CPU and RAM is being used. Now, at night, obviously, all the virtual machines would not be used. Well, no one is suppose connected, or very few users are connected. So all the virtual machines will say that they don't need a CPU and RAM. Maybe they're on 20% CPU and RAM of the hypervisor, maybe on 30%, or maybe even 10% of CPU and RAM of the hypervisor is being used, right? So DRS will calculate and it will check that. So suppose I can migrate the virtual machines of suppose these 6 hypervisors to the rest of other 6 hypervisors here. Right now we're seeing 6. So suppose if it was 200 hypervisors, so I can move the virtual machines of 50 hypervisors across all the other 150 hypervisors. And still, because nobody's using the virtual machine, so it's not using CPU and RAM. So even then, the hypervisors will not be consuming a lot of CPU and RAM, right? So 50 hypervisors worth of virtual machines will be migrated at night to the rest of the hypervisors. And then those, suppose these are 50, so 50 hypervisors will then be shut down, right? So in the morning, when the users start coming in and they start connecting to the virtual machines, now the virtual machines are consuming more CPU and RAM, and that because more virtual machines have been spread across lesser amount of hypervisors, so hypervisors will start losing more CPU and RAM, and they might reach even faster to 90% of consumption. So power management of DRS will check that, and it will remotely send a power on signal to these hypervisors. They are supposed to power on and then automatically move the virtual machines that were moved last night away from those hypervisors. Those virtual machines will be moved back to those hypervisors again until the CPU and RAM usage is on normal level on the rest of the hypervisors where the virtual machines stayed all night, right? So this is a whole process of saving electricity. How the DRS power management simply checks and analyzes that how many virtual machines they can migrate away from how many hypervisors. Then they do that, and then they power off the hypervisors, shut down the hypervisors, and electricity for the whole night is saved. In the morning, when the users start connected virtual machines, underlying CPU and RAM usage goes up. Then it simply remotely starts, send the command of start to all the hypervisors, and then move the virtual machines to those hypervisors. The only catch there could be that before enabling this feature, you need to make sure that power on LAN feature or remotely sending a command to start the hypervisor feature is actually working. So suppose they are older physical servers and you tested and 1 or 2 of the physical servers did not start, uh, 2 out of 10 times, and all the other servers started 10 out of 10 times. So whichever did not start 2 out of 10 times, then you have to not include them in the power management plan, or just simply if you want to implement that plan, you can just change it with newer physical servers and check them with Wake on LAN feature if they start at a specific time automatically from a shutdown, right? So that is power management feature. And power management. So it's pretty interesting to know that, that automatically the hydro bill for the company can be controlled as well, and less electricity can be used, and hypervisors could be actually shut down all night, given that they start the next day. Okay, so so I'm not gonna actually power them on. I'll just disable them because I don't want my machines to be shut down if I'm not using and for a certain time. Okay, then comes advanced options. Advanced options that we talked about before as well. You can just contact the support, and they're used for wherever you want those features that are being offered in these windows be changed. If any of the main features behavior needs to be changed, then you can go for advanced options and reverse some of those features. But you have to get that code from the support or take down some VMware documentation for that. So we go ahead. So we talked about DRS here and power management as well, and we talked about vSphere availability as well. And then there is EVC here as well. And EVC is enhanced vMotion compatibility. So what EVC does is, EVC is enhanced vMotion compatibility, and what it does is that EVC helps the vMotion feature into thinking. We can also say that EVC fools the vMotion feature into thinking that the processor features of the source and destination hypervisors are same. Right? So PC also vMotion feature into thinking that the processor features of the source and destination hypervisor are same. So this is definitely, we talked about during vMotion as well, that the vMotion will only happen. We already know that vMotion will only happen if the source and destination hypervisors have processors belonging to same vendor and generation. So I told you at that time as well, when we were talking about vMotion and processors, that I will show you this with the feature called EVC, on enhanced vMotion compatibility. Now is the time to see that. And this feature has to be enabled for the next lab, which is very, very critical, called fault tolerance, or FT, right? So that lab has to be also done, and it requires EVC to be enabled. Now, enabling EVC in our labs is kind of a tricky thing. So what EVC does is, in fact, let's just go ahead and see that. So I'm going to go for VMware EVC is disabled. So I'm just going to click Edit. It opens up Disable EVC and then Enable EVC for AMD hosts and Enable EVC for Intel hosts. So, those of you who have a laptop with AMD processor can go here, and those, including mine, I have a Intel processor. If we don't know, we can just go to this right click here, and we can go for this information, right? So info, system information. In the search in your Windows, you can go to system information, and then it just tells you that it is Intel in the processor. So system summary, processor, is it Intel or AMD? First of all, you need to know that, right? So if it is, I have Intel i5, and now I'm going to go to the Intel side here and select it. And then it says that is my current processor belonging to one of these generations, right? So MEROM generation, Xeon. Xeon is actually used in servers, right? HP servers, Dell servers. But once, first of all, I'm going to check that. So if I go way down here and MEROM generation or this is selected, MEROM generation, right? All the generations are showing there. So does my processor belong to MEROM generation? It says the host cannot be admitted to the cluster's current enhanced emotion compatibility mode. Powered on or suspended virtual machines on the host may be using CPU features hidden by that mode. So in English, it says that no, your laptop processor is not belonging to MEROM generation because that it's not green, it is red. So I'm going to go for the next one, and you guys need to do that too, because we need EVC to work. Okay, my processor is not also belonging to Penryn generation, and we go ahead. Nehalem generation, nope, it's red. And Westmere generation, maybe it's green, 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 no, red. And Sandy Bridge, my previous machine was actually belonging to Sandy Bridge, but this is not, it's red. Then I'm going to tell you the hack in VMware Workstation, because it needs to be compatible, recommended, otherwise you can't do the FT lab. Then Haswell generation, oh, serious? Broadwell, no. Skylake. So first you have to check if it's AMD or Intel, and then go for that and check all the generations. Cascade Lake generation. So obviously, our laptops are home laptops, right? Uh, they're not servers, first of all, and this is for servers, HP servers, Dell servers, and Dell Blade servers, rack servers, right? Servers, not, or this is the heavy machines, not the home machines. It's not made for that. But now I can see that none of those generations actually my processor belongs to, because they're all showing me this red compatibility, which means it's not compatible. Now, if I press OK on any generation that is showing red here, and if I press OK, so it shows this error. CPU hardware does not support the cluster's current enhanced emotion compatibility. So it's going to stay disabled. It's not going to be enabled. And we need it enabled for the next lab. First of all, I see that all 4 machines are started. I don't need them started anymore. So I'm just going to power them off just to free up the RAM, which has nothing to do with EVC, by the way. It's just I noticed them and I'm powering them off just to preserve. So I'm power off. Yes. Power off. Yes. And it has nothing to do with EVC. But now I'm going to show you that what's the hack where either it will support one of the processor generation for your CPU, laptop CPU, or actually it will show that your CPU belongs to all those generations. Ha, so funny. But anyway, the thing is that we need to make it work. It has to be enabled in order for us to proceed to the next lab, which is very, very critical fault tolerance lab. So what we can do is that because we're doing the lab on E6i 2 and 3, right? So if while it's powered on, I'm just going to check the processor settings here. I'm just going to go right click on the E6i 2. I'm going to go to settings here. And then processors. So performance counters, that is unchecked. I'm just going to check that, and I cannot check it while it is powered on. So I'm just going to shut it down. I'm going to check it and then power on, right? So what we saw is that if you do that, IOMMU, and pretty much all 3 are selected, but this one, which is not selected, select that too, and then power on, and then check again EVC, and it should work. It worked for majority of the students in previous batches. So what I'm going to do is I'm going to shut down E6i 2, and I'm going to shut down E6i 3, and go to processor. Once it is fully shut down, go to processors, and then check mark this virtualized CPU performance counters, right? So, and then come back and try EVC again. So I'm just going to right click here, go to properly shutting down, right click, power, shut down guest. Once it is shut down, then we go to the processing feature and enable that counters feature as well. And A6i2, I'll go to edit virtual machine, processor. I'll select this one as well, virtualize CPU performance counters. Okay, power on, go to 6i3. Okay. Nope, it's not powering on when I enable that. If I disable this and enable that, does it work? Didn't let me power on. Nope. So the performance counters require at least one available functioning counter. Module BPMC power on fails. Failed to start the virtual machine. Okay. I will keep it there, but it was there already, and our our ABC did not work. So I don't think I'm gonna find that VPMC virtual power management console. I just made it up. Okay, so because we were enabling one of this option, so I'm gonna go crazy now. I'll uncheck this option now and power on, then I'm gonna shut down and check this option. Well, for now, I'm unchecking this option because with this option, it actually EVC did not detect our processors to be compatible. While what I remember is that this was already unchecked and we had to shut down, and then we checked this option, IOMMU, memory management unit, and then EVC said, oh yes, now I detect you are compatible. So I'm doing the opposite of that because we don't have any other choice. I'm gonna go for, okay, both hypervisors. So that was the hack actually, and somehow it was already clicked on the third option. Start. Yeah. So yeah, they are detected again. Supervisors should be detected. Okay, they are detected, and cluster services are starting. ABC is disabled, so I'm just gonna go ahead and check for Intel. Oh, they are compatible! Yay! Okay, it worked. The opposite as well. So those IOMMU that was unchecked, and then it is now saying validation succeeded. Yes, your processor belongs to laptop processor belongs to Miron generation. But if I go to any other generation, does it just say yes to all? Oh yeah, it's doing the same thing. It's saying yes, your processor belongs to every generation or not. Not every generation. Okay, Skylake is not, but I'll just quickly go to Miron or Cameron. Yeah, we just want this validation so we could power on the EVC mode, and that should help us go for the FT. All right, so let's take a break and then go for the next important topic, which is FT, fault tolerance. All right, so resuming now, and for oh, so there's that FT feature, and that is fault tolerance. So FT offers zero downtime. We zero downtime, so we must have two VMs. One is okay. In VMware, it's called primary active, and secondary standby slash passive. And so the active VM does synchronous replication. Synchronous also means same time replication to its passive VM. In case of a disaster with active VM, the service connection information is all failed over instantly to the service connection information is all failed over to the passive VM. So synchronous application, it's always requiring more, we can say, bandwidth. So synchronous application happens on LAN and requires more bandwidth. And down to the last change that has happened on the active VM also is copied to the passive VM. So that's why nothing is lost and there's a zero downtime there, right? So on the in the cloud, between the regions of the cloud, this replication is asynchronous. It's happening over the WAN, wide area network, and there's always a downtime in asynchronous replication because there's a wait time between the changes happening in the active virtual machine or active site, and then that change is copied to the passive site, and there's a wait time there. While synchronous replication, the synchronous replication just offers same time copying, hence using a lot of data bandwidth, hence also that it's going to be offering zero downtime and no data loss. So FT offers zero downtime and zero data loss, right? And obviously we need to create a VM kernel adapter for that as well. And just like we had to create a VM kernel adapter for our virtual machine or vMotion. So we will have to do that for FT as well. So I'm gonna open that FT slide as well and show you, and then we can just follow the lab for that. So fault tolerance itself has been around for a long time, and okay, so that was all old, but yeah. So vSphere fault tolerance provides instantaneous failover and continuous availability. So zero downtime, zero data loss, no loss of TCP connections as well. So a virtual machine here is the primary and the virtual machine here is the secondary. And there's a fast checkpointing going on that from last checkpoint, whatever changes happened here are instantly put or copied to the secondary virtual machine as well. At any time the crash happens, the secondary virtual machine is supposed to be fully updated to the last second with any changes that were made on the active machine. So it's pretty secure. And then yeah, it's 4 virtual CPUs. It supports 64 GB RAM, actually much more than that. It supports its common features. And it supports 10 provisioned memory virtualization and EVC, enhanced vMotion as well. But there's one more thing that it does, and that is, suppose there are we have 2 hypervisors, right? But if there are 3 hypervisors, so what happens is, suppose the first hypervisor had a crash, or the active VM on the hypervisor had a crash, so, or the primary virtual machine, then the secondary becomes primary, right? And secondary will not wait for the actual the original primary to come back up. Maybe the server crash was longer and the cause of that is not resolved soon, or the server restarted after the crash, but the virtual machine still is not up. So in that case, the secondary that becomes the new primary will not have a partner for that long. So it's not going to be redundant. And if the crash happens here as well, then the only primary that we have, which would be the new primary, would also be lost. So it at once creates, as soon as the secondary becomes the new primary, it creates its new secondary as well. So as soon as the failover occurs, it would want to go to that redundancy state right away. So it just creates its exact copy in another hypervisor and gains that status of redundancy right away. So that's a pretty cool feature there that is automatically happening there. So that's pretty cool. And other than that, those are just primary and secondary. So they're in the partner virtual machine, as its VMDK or virtual disk files should also be there on the other data store. So now how it really is supposed to work is that suppose you have a virtual machine here and here, and its copy is here. Okay, let me just have to change the color. Suppose there's a virtual machine here and its secondary VM is here. So the synchronous replication will happen between the two, and this virtual machine will have its virtual disk on obviously one of the data stores here, and its virtual disk will be here, and its exact copy virtual machine should have its virtual disk in a separate data store, right? So if this virtual machine has its virtual disk also in the same data store, then the redundancy is not achieved, obviously. So if this virtual machine's virtual disk is also there and that virtual machine's virtual disk is also here, if this data store is lost, although the two hypervisors are just okay, virtual machines itself are okay, but their virtual disk will be gone for both if they are both having their virtual disk on the same data store. So the secondary or passive virtual machine's virtual disk and other files of the virtual machine should be on the second data store. And then once that is achieved, then obviously that synchronous replication then starts and going from primary VM to secondary VM. So primary VM is the active VM, and then the secondary VM is a passive VM. Okay, so that's how it really works. And I would go directly to the lab because pretty much we have talked about this in a diagram as well. And before that, in the slide, I wrote that. Now this lab steps mentioned that increase the memory of E6i1 and SI2 from 4 GB to 8 GB. We increased it to 6 GB, which is good enough. And vCenter memory, VM memory as 8 GB. So this is already, in my case, it's 12 GB because my machine can actually take 12 GB. The second thing is that have two data stores available. So we have actually 3 data stores available. So that's also no problem because the secondary virtual machine's virtual disk should be on a separate data store. Third thing is that turn on EVC mode in cluster settings. So we did that too. If we go ahead and check it, so EVC is enabled, yeah. And vMotion must be working. We actually tried that just a few moments ago. That for DRS, vMotion was working fine. And then we have to actually create a network adapter and new VM kernel port with FTE logging enabled on both hosts and assign them both to unique static IP addresses. So this we need to create, just like the VM kernel port we created for vMotion. We're going to be creating a VM kernel port for fault tolerance as well. And then we're going to be actually creating VM kernel port for vSAN and next class. Choose any VM shutdown that is on shared storage. So yeah, we're going to be going for a virtual machine. I'm going to convert it to fault tolerance. And we're going to go for some empty virtual machine because obviously fault tolerance will work the way on an empty virtual machine, the same way it's going to work on the virtual machine with an operating system as well. It's the same way. But because of our environment, we're going to go for an empty virtual machine. Now, RAM or resource sufficiency is a sensitive issue with fault tolerance. So fault tolerance gives errors right away if there's a slight insufficient resource problem here. So it's going to give errors right away. And T-shoot, if there are errors, then make sure that a VM has 1 GB. Please check which data storage is on, turn off FT, and then change the memory if you have to do it, and then turn on FT again. Suppose you wanted to change the RAM of the virtual machine, then if it is enabled for FT, then you cannot change the RAM of the virtual machine. You have to turn off FT and then do that. You need to have HA and EVC enabled. So do we have high availability and EVC enabled? I think we do. If we go there, so EVC is enabled, and if we go to availability here and click it, so yes, both are turned on. And if we are still low on CPU and memory according to FT, then we can visit admission control feature of HA and turn it off. So we did that already as well. If we go to availability, so Tor cluster, configure availability, and then HA is turned on, edit, and admission control. So this is disabled. So make sure this is disabled. EVC is enabled. Admission control is disabled. Now this admission control is supposed to be disabled just for our lab. In production environment, it should not be disabled. It should always be enabled. In production environment, in companies, you will have enough CPU and RAM, obviously. And if we go back here, we are still okay. So we're kind of ready, but we need to do this. We need to still create a VM kernel report that creates network settings for all the advanced features. So we're going to go for VM kernel port or VM kernel adapter. How to do that? We're going to go to E6i2 first, whichever hypervisor is taking part in this. We will have to configure the VM kernel port or VM kernel adapter for that. And so I've clicked that and then configure and then virtual switches, but under the virtual switches is VM kernel adapters. So VM kernel adapter for two advanced features we have already seen. The vMotion, we've used actually 200.5 address, and 5 and 6 we use for vMotion. So for fault tolerance, 7 or 8 IPs we're going to use, right? So we're going to go for 200.7 for E6i2 and 200.8 for E6i3. So I'm going to create that on E6i2. We're going to make E6i2 hypervisor ready for fault tolerance first. So I'm going to click that add networking here. And as a best practice, we're going to create a new switch and we're going to attach two new dedicated network interface cards. So I'm just going to go for this VM kernel network adapter. Yes, this is what we are creating, and we are now adding this feature, fault tolerance. And I'm just going to click next. And we're going to go for new standard switch. Next, assign adapters. I'm going to click plus sign, and then I'm going to go for VMNIC 4, VMNIC 5. So because we have more network adapters, so we can actually do that. So we're going to go for the best practices, just assigning a new feature with its own set of two network adapters to regulate their own traffic. And press OK. And next. And we can call it anything. So we're going to call it FT, fault tolerance. We're not enabling any VLAN. We're using IPv4 settings here. MTUs remains the same. Static TCP/IP default is okay, and fault tolerance logging. So this is what we need to enable. And once clicking that fault tolerance logging, we're going to click next. And then as we decided, we can go for the IP address 7 and 8. So it's already showing here. I'm just going to change this to 7 for ESXi 2, and for XSI 3s, we're going to go for 8. Next, oops. Yeah, we have to give 255 to 55, we'll have 0. Gateway, we don't need to change. We're going to keep it as is, and DNS, we're going to keep as is. So no changes here. I'm going to click next. Yep, it's ready. And we're going to go for IP address 8 for the V6i 3 fault
So-
tolerance. Yep.
So can you go back?
Yeah. More?
Yeah, yes. Like one more. Right.
And from here, right? Or even
Select target device.
target. Yeah, so I was on the 6i2 configure
Right.
VM kernel adapter, and then I click this
Right, yeah.
add networking, and then yes, this one, first one, and then click next. Then I went for the third one, new standard
Okay.
switch,
Okay.
and then next. So then I had to add 2 new network cards, 4 and 5, and then press OK. And then next. Then we name it as FT. No VLAN change, no IPv4 change, no MTU change. So stack remains the same. We can go for fault tolerance logging, and then next. We then give the static IP, although we can give dynamic as well on DHCP. We have a DHCP. Best practice is to go for static. 2.7 we're giving here, and 255 subnet mask. And once that is done, we're ready next. And then
Finish.
finish. Okay. Now, this is for A6i2. So A6i2 is ready for fault tolerance. I'm going to go for A6i3 and do the same exact steps. So it's A6i3, configure VM kernel adapters, add networking, VM kernel network adapter. Next, new standard switch. Next, plus VMNIC 4, VMNIC 5. Okay, VMNIC 4, 5, right? So it's pretty much the same thing we're doing here in E6i3. And then we have to change the name to FT, or it could be anything. And then with an ID, IP settings, MTU, default. So we're going to go for fault tolerance logging. And then we're going to click next. So best practice static IP. I'll go for 8 here, change to 8. 255, 255, 255, and next. That's it, finish. So the 2 hypervisors are also ready for fault tolerance. And so we can go to E6i2 here, and this VM kernel adapter, we can just take a screenshot of this on E6i2. Then the second screenshot would be E6i3. So fault tolerance configuration fault tolerance on E6I2 will be the label for first screenshot. Fault tolerance on E6I3 would be the label for the second screenshot. I'm going to go for the first screenshot here with E6I2, configure VM kernel adapter, and well, all the VM kernels adapters showing here. So I'll take a screenshot of that. And put it to screenshot 1, where we should be saying FT on ESXi02. I'll take that screenshot. And then we're going to go for the second screenshot. I'm just going to select the A6i3 to show us the same view. Configure Windows adapter and Windows adapters. And that would be called FT on A6i3. And that would be, yeah, FT on ESXi03. Okay, they're on WhatsApp as well. And that screenshot that we and yeah, I'll either upload the slides here. There's a lot of that one. Okay. Screenshots. Okay. Now let's go ahead and try to go for next steps. So as we're talking about or checking this, yeah, we've done this, creating VM kernel adapters, and the rest, EVC is on, HA is on, vMotion is working, yeah, and 3 data stores are there, and the 2 hypervisors are there. So we're ready to, and addition control is also off. So we're kind of ready to go to a virtual machine that has no operating system. And you can always do that on the virtual machine that has an operating system. It's just saving some performance here. So I'm going to go to this and I'll choose VM02. It has no operating system. First, while it is shut down, we're going to enable the fault tolerance. And fault tolerance, it says here, turn on fault tolerance. So we need to make sure that, or we need to know which hypervisor this is on. And so we're gonna put its partner machine. This will be the primary, and its secondary machine needs to be on the other hypervisor. So this is on E6I2 hypervisor. That's the first thing. Second thing we need to know about this machine is which data store it is on, right? So if I keep it selected and go to this data stores view, so it's on LUN1, the DS1 LUN1 data store. And if I go back to summary, it's on E6I2. So these 2 things we need to know. because its secondary has to be from on the data store other than this, and on the hypervisor other than this. Okay, so E682 and LON1. I'm just going to right click on it, VM02. So if you're following, then you can see maybe your data store is different and maybe your hypervisor is different. So make sure, according to your information, its secondary should be on a different data store and hypervisor. I'm going to go to the fault tolerance and turn on fault tolerance. Just merely turning it on starts giving us error, but hopefully our increasing the 6 GB RAM to the hypervisors should resolve the issue of insufficient resources, unless there's another error. So I'm just going to go for turn on fault tolerance. And yeah, so before this screen, it normally gives an error. If not, okay, sure, John. I'm gonna just select one other than this, 1.3, and then I'm gonna click next. And yes, that's the other only hypervisor that it shows. Yes, that's the one. So that's where the it clearly says here secondary VM will be on. So I'm just gonna click next here. So secondary VM's configuration file location will be 1.3, and then tiebreaker file location will be 1.3. Tiebreaker file is for checking that if the active primary virtual machine is available or not. If not, then it says that, hey, secondary, you're the primary now. So that is going to be on this location, and hard disk one location would be, so secondary virtual machines hard disk will be on this location, obviously. Location of the data store other than the primary virtual machine's data store. So that once that is all done, then we're going to go for finish here. So you can see the icon will change. It's going to go dark blue, I guess, or it's going to be different than, yeah, there you go. First, it shows dark blue, and second thing is it shows that this machine is primary now. And where is its secondary then, if it's primary? So we have to go to this view of VMs and templates section to know that. So I'm just going to click this oops, sorry, it's not this section. I'm just going to go back to hosts and clusters, and I'm going to go on the hypervisor level view. Then we will know. So I'm going to go on E682 where our and E682 and the VMs. So E682 hypervisor and the VMs. So if we go to that, so yes, there's our primary here. And if we go to E683 with the same VMs view, then there's our secondary here. So E682 has primary and E682 has its secondary machine. Now we will power it on as well. So without powering it on, if I right click here, select the machine and then right click here and fault tolerance. So it says turn off fault tolerance and suspend fault tolerance, migrate secondary. So secondary is only 6i3, and suppose you have V6i4, 5, 6, 7, 8, 10 hypervisors. I'm just going to, the fault tolerance shows this while it's powered off, and it can migrate the secondary to any other hypervisor from where the secondary VM right now is. But if we want to, then we can do that. But these are the options enabled when we are like powered off. So I'm just going to right click here and I'm going to power on the machine now. Hopefully no error pops up. Power on. Oops, there is an error. The available memory resources in the parent resource pool are insufficient for this operation. Seriously, are you kidding me? Okay. So this is on E6i2. I turned off all the other virtual machines, and E6i2's RAM is also 6 GB. 6 actually works, but maybe we have to push it to 8 GB. It used to or supposed to work with 6 GB still, but it's giving me the memory error, which I was not expecting. So obviously the memory would not be available. You know, it would not be available if the admission control was enabled, but we know that admission control is disabled. So if I go to Tor cluster and go to availability and then go to HA and edit, and we know that admission control is disabled. So we can use the memory of other hypervisors. Okay, any other thing that I may have turned on and was not supposed to be? So I do remember. It's not about not supposed to be, but something that I turned. No, it was already on here. Additional options. I turned on actually some option here that normally I don't turn on in courses. Migration social. No, everything's okay. We're kind of good here. So if it's insists that memory is not, what is the memory I actually gave to this? Memory is 1 GB. Yeah, that's what I'm supposed to give. And even I can go 0.5 GB for this just to make sure that it powers on at least. Or I could just restart this hypervisor again, E6i2, and it would then clear up any memory that was stalled because of I started all 4 machines and some memory might not have gotten free from those virtual machines. So kind of a crazy thing, but this is not supposed to happen. So what I'm just gonna do it, I'm gonna restart this. Go to E6i2, right click it and power and reboot and reason FT memory issue. And well, E6i3 since 2 is restarting, so why not 3 as well? So I'm just gonna go for 3 FT memory issue. Yes, okay. So there are 3 VCLSs also started, so that could have also affected. They normally take 1 GB only. Ultimately, if that restart doesn't resolve, then we have to change the memory to 8 GB just to have this lab working. Well, that takes time. But restart should do it because the 6 GB is supposed to. So 1 GB for VCLS and 1 GB. So what hypervisors VCLS are using right now? I just restarted both, so we would not be able to know that because it's any one of the hypervisors the VCLS will be using. In fact, if I go to virtual machine area, the VCLS we're using is i3, which is restarting. And each VCLS takes that storage. It takes 0.13 GB. It's very, very less memory. .13. VCLS 2 GB just the space, and it takes very, very less RAM. Okay, so yeah, the 2 machines hypervisor was restarting. It's nearly done and nearly restarted. Yeah, it's reporting to vCenter that it's back. And now I'm just waiting for this guy to do the same. 6i3. Should bind. Yep, there it's also reporting it's back. Well, it's back and there's no activity going on in the recent tasks area. Sometimes the back, oh, there you go. See, some activity started here. So VCLS are actually trying to power on as well. So we could wait, we should always wait for certain activity in the background. Okay, I'm gonna start again. I'll go to primary and right click. So power on, yeah. Obviously, restart. Why should restart? Resolve memory issues. The memory resources in the parent resource pool are insufficient for the operation. Seriously. It's 6 GB, so yeah, I'll make it 8 GB on both. So it could start, or there's just 1 GB. It's asking. So what is available memory on E6i2 anyway? If I go to summary of E6i2 here, and summary, so it's used is 1.4 GB and 6 GB. So that's still 5.6 GB memory is available. What is wrong with this, dude? How can it say it's not when it has enough memory available here with E6i2? Hmm. Nothing here. We can see that it's enough memory here. And if I go to the virtual machine here, so it says 1 GB only. It's using 8 MB card. What I can do is, it's crazy as well. Well, the error is crazy, so I'll go for lesser than that. So if it takes point, oh, 500 MB. Reservation 1024 MB or reservation is minimum. Reservation must be 0 MB and 500 MB. So yeah, reservation 500 here as well. Oh, you know that reservation we made, but I had actually removed that resource pool. And when we were talking about resource pools at that time, but that resource pool itself is gone. Anyway, I put the memory to 500 MB. It's an empty machine, so memory size reservation limit or shares of the virtual machine cannot be edited while fault tolerance is turned on. Seriously. So it says that turn off fault tolerance and then change the memory and then go back. So okay. So I'm just going to turn off fault tolerance. Yes. I'll change the memory quickly. Both. When I turn off fault tolerance, obviously the secondary machine will be gone. Secondary will be gone. And then I'm going for and then it says reservation, make it 5 as well. Reservation means minimum, at least, right? So limit means maximum, reservation means minimum. Okay, it's 500 MB now, and I'm just gonna turn on the fault tolerance on it again. Obviously, if I go to 6i2 and then VMs, because it's out of fault tolerance, so it's not going to show primary. And if there's no primary, there should not be any secondary as well, right? So I'm going to go to, well, I tried on 6i2. Well, okay, I'll just try it on 6i2. Otherwise, if it just gives the same error, I'm just going to go on 6i3 and check it out. Maybe 6i2 has some other issue that's causing memory related stuff. So I remember that VM02 was, but site 2 and data store is 1 1. Okay, so nothing changed. And I'll go for fault tolerance again. 1 3, whichever other than 1. And A6i3, that's the target. Finish. So it becomes fault tolerant with primary and secondary virtual machine, but then we need to power it on as well. Even if we are not able to power on, we'll still be able to show that fault tolerance works with a crash test of hypervisor. But if I go to 6i2 VMs, yeah, it shows primary, 6i3 shows secondary, and it's powered off, so I'll just power it on. It's ridiculous that it has enough RAM and still it says not enough memory. You kidding me? The memory resources in the parent source are insufficient for the operation. Okay. So what I'm gonna do is I'm gonna turn off fault tolerance on this machine. I'm gonna go for VM03. For some reason, it's just not able to see the enough memory that is available. And also I'll refresh. Once the fault tolerance is off, then I'll need to refresh here. Okay, refresh. Still turning off fault tolerance on VM02, which means it's removing the secondary. I'll try it on VM03 now, which is also 1 GB, but wait for this to be over.
Hello, sir.
I think we lost it.
Xavier.
Wait, what?
Yeah, I think no. It's coming. It's coming. Yep.
Xavier.
Yep.
When I try to enable the fault tolerance, I am getting one error. Fault tolerance configuration of the NIT 2.200 has an issue. The virtual NIC associated with the host has insufficient bandwidth for vSphere fault tolerance login. What shall I do?
Oh, no. Thank you for the question.
Okay, so yeah, you can share your screen and we can see the error, or you can take a screenshot. So,
Share.
wow, so now fault tolerance here is not tolerating the fault. Fault tolerance configuration of the 200.2 has an issue. The virtual NIC associated with the host has insufficient bandwidth for vSphere fault tolerance following. What? Okay, so you can click yes and yes or no, whichever, doesn't matter. Yeah. Oh, it goes ahead, but then it doesn't show anything, so cancel. And go to how is it figured here? Okay, can you minimize the Tor cluster? Tor cluster written, if you can click the minimize. No, there's an arrow. Yeah, this one. Hey, you didn't add the second hypervisor inside the cluster. So drag it inside the cluster now. Yeah, drag it inside. So both hypervisors have to be inside the cluster. Yeah, press OK. And yeah, let it go to the process. And you have to configure. So go to 200.2, VM kernel adapter is there. Okay. Go to 3. 200.3, and you put the VM kernel adapter here as well. So yes, there are things going on at the bottom, recent tasks. So when those things are finished, then you could put a machine on fault tolerance. Yeah, go for a machine and start doing, although it's still doing some processing. So if the processing in the background hasn't stopped, yeah, go ahead. So it might not work for you. Now after, well, you have to wait a little more because now you just added 200.3. So it's gonna, yeah, take some time.
Okay.
If it still keeps on coming after some time, then restart both ESXi 2 and 3.
Okay,
And
okay,
then
sure.
try again. But the second has to be inside the cluster. Was the main thing.
Thank you.
Welcome. I'll go back here. Oh, it's now stubbornly stuck. So if I just put the power and hard stop, that would work. That's but how does it remove fault tolerance from it? Anyway, this machine is really giving problems. So I'm just going to go for another machine for fault tolerance while that machine processes its things. Because we know that on cluster level, it actually checks, in summary, it actually checks the memory that is available collectively for the two hypervisors. But yep. Participants and also chat. Okay. So while this is kind of stuck on 2, VM02, I'll go for 3 if I'm able to do that because it might be resolved if I restart this hypervisor. So just to try to avoid that and test it on VM03, turn on fault tolerance and then go for, oh, I need to check that VM03 is on SXI2, okay, and its data store is on LUN 2 actually. So LUN 3 or 1, I can put the secondaries data files. So fault tolerance turn on, let's see. And then its data store is on LUN, its files are on LUN 2. So I'm just going to go for LUN 3 here. And it's going to offer me E6i3 because its primary machine is on E6i2. Let's select that. Next, pretty much the same process. We just need to know what's the current data store of the primary and what is the current hypervisor of the primary. So yeah, 03, the recent task says the VM03 is okay. VM02 is stuck for something, for some reason, we can always attend to it later. So 3 is okay. And if I go to ESXi 2 and go for VM's view, so yes, VM03 primary is showing, and ESXi 3, VM03 secondary is also showing. I need to power on the primary. Hopefully that it just powers on and there's no machine level issue here. And there you go. Actually, it has to memory resources and the parent resource. Same thing. Okay, that does it. I'm gonna increase the memory to 8 GB. Right click it 6 GB for hypervisor. It's now we're gonna kind of overcommit because if you put it to 8 GB and hypervisor is 16 GB, so 16 plus 16, 32 already, plus 2, 34, while my maximum is 32 on the physical machine. Yeah, guys, you can mute the mic. Okay, so here the first machine is down and 6 GB did not do it. I'm gonna go switch to 8 GB and power on. And so E6i2 is now 8 GB, I'm just gonna power it on quickly. And it's still shutting down. E6i3 shut down. I'll quickly move to 8 GB. And power on the two machines now. Although I overcommitted now, it's total of 34 GB RAM being used by virtual machines while I have only 32. But it actually, the usage level could be still on 28 GB or 26 GB total actual usage of the virtual machine. They might reach up to 34 GB collectively, but for whatever we are doing, that's not causing more memory consumption now. So it's sometimes overcommitting. It does not actually uses that much RAM. Okay, with 8 GB, they're both nearly on. Yeah, they're detected by, I'll just refresh that. Are they detected by the vCenter as well? Yep, they're detected. And it's still on, well, there are some VCLS machines that are trying to power on. I'll give them time as well and refresh some more here. So now I'm going to try to power on the VM03. The available resources, memory resources in the parent resource pool are insufficient for the operation. Okay, what's going on here? 8 GB is also, oh, actually it powered on. While giving an error, it powered on. Did it? So I'm going to go to E6i2 here and check the machine itself. So, okay, summary of the virtual machine itself. I'll click that machine and summary. And it says powered on actually. So it is powered on. It just says that it's not enough memory then. Okay, so I'm just going to right click here and see the fault tolerance. Yeah, resume fault tolerance, migrate secondary still are there. So this is the primary virtual machine. I'm just gonna on the E6i2 level, it is showing primary, and then I'm going to go for E6i3, and that's the secondary. It's disabled, it says. I'm going to right click here and go to fault tolerance here as well. So none of those are showing. So the thing is that with this, there's memory issue going on. Maybe it may need some even more memory. I could just try to go for some more configuration, which machine failover, which machine fault tolerance state changed. You know what? I'm just gonna shut it down because I need to show you that primary automatically changes to secondary, powered on or powered off. I'm just gonna power off the primary because somehow the secondary is not starting cause of still the memory issue, which needs to be still seen. So I've shut down the primary here, or at least given it a command. So I have, is it powered off? Yeah, it's powered off now. So it's not taking any memory. I'm just going to go E6i2 level, and I'm going to check its primary, and E6i3 level. I'm going to check that it is secondary, but it should not be saying disabled. Or since I've increased the RAM of the hypervisor, I'll just turn off the fault tolerance once more and then turn it on again, at least just to get that disabled away and keep it shut down, and then I'll show you that how they still fail over properly. Okay, so fault tolerance is gone. Also, this VM02, I don't know why it's showing. Oh yeah, it's powered on, so I'm just gonna power it off. Fault tolerance is gone from both machines. I'm just going to go for VM03 again and make it fault tolerance, but I'm not going to power it on. But still, I'm going to show you with a hypervisor crash test that whichever is primary after the crash becomes, whichever is the secondary after the crash becomes primary, right? I'm going to show you. So whether the machine is shut down or started, it works the same way. If the crash happens, secondary automatically becomes primary. So that's what I wanted to show you. So I'm going to go for VM03. I'm going to enable the fault tolerance again. But I'll obviously I have to choose again. I think it was on 3, so I'm just going to put it to 2. Right in the check succeeded. And its partner will be living on 3. So it says that 2 is being used for both primary and secondary. So I'll go for 3 for secondary, right? And now it's okay. Sorry, 3. Next. Finish. So I'm enabling fault tolerance again on this, and not gonna try to power it on because of, I think, still the memory is less overall. So, but I'm gonna still be able to show you that if we go to 6i2, it's the primary of VM03 is there. If I go to 6i3, the secondary of VM03 is there, and it's not saying disabled, right? So the fault tolerance feature is there. Now, what I'm going to do is, just to show that fault tolerance really works, I'm going to crash the E6i2 hypervisor, this one, right? What we're expecting is the E6i3 showing secondary should automatically show primary here. The status secondary should change to primary, right? So wherever is primary, we can crash that, right? Not the secondary one. Wherever the primary virtual machine is, we'll crash that because primary is where the end users connect. So I'm going to go for E6i2, right click, and crash is power off, right? So it crashed, and I'll go for refresh here because vCenter has to detect that E6i2 is no longer available, and that heartbeat reaches in soon. So I'll refresh that until it goes red here, E6i2. 2 is not available, and one day, Monday or Sunday, it's going to detect that. So I'll go refresh the whole browser. Oh, yeah, it detects that 6i2 is gone. And if I go to 6i3, so it still says secondary and refresh. So one day, Monday or Sunday, the secondary. So 2 was primary, right? Yeah. So I'll just refresh the browser. What we're expecting is that secondary should say primary now. Okay. Secondary is still not saying primary. Is it sorry 3? Yeah. It does say VM03 is now primary, and it does say its secondary is also created. What I mentioned before, that it automatically creates a secondary as well. But primary was not there on SXA3. It was only secondary before, right? So when we now see, so not only that it created its primary, but it also created its own secondary, which we discussed in the slides before. So it now shows secondary here as well. But primary was not there, we know that. So the secondary became primary and it created its own secondary. But now this redundancy is not that good, because if primary and secondary are on the same hypervisor, that's not good. But we only have 2 hypervisors. That's why we have no choice. We have to really work hard on getting the hypervisor to back up again, so the proper redundancy could be achieved. Right now, both machines are on 3 because it needs to have redundancy still, right? It needs to have redundancy. So it created it when it didn't find a third hypervisor. Although we have third, but we didn't add it to the cluster. It's just a VIP hypervisor hosting the vCenter. So the only experimental hypervisors are 2 and 3. It tried to search for 4th hypervisor. It couldn't find it, so it created its secondary on the only available hypervisor in the cluster, that is 3, right? So that's good. But if we had more hypervisors added to the lab, obviously, it would have created automatically its own new secondary on the other hypervisor. It couldn't find it, so it created it on the same. Now I'm just gonna go ahead. So fault tolerance really works. We can just put this screenshot here where one is crashed and the other one is the only one that is up, and it has its secondary, which was there, is now primary, and it has created its own new redundancy status by creating its own new secondary on the same hypervisor. So FT works. That would be the screenshot number 3. Okay. So yeah, now we're just going to power on the site to back up and see if it detects that and automatically creates its secondary there, or HXI2 had primary, right? So let's see if primary comes back there or the new secondary goes to ESXi2, that is coming back up. Okay, let's check it out. So yeah, it's nearly up. And if it's detected, it is actually detected, and I'm just gonna refresh that. So who got primary? And so right now, if I go to 3, that's the primary, secondary both. Does it automatically moves it, or we know that feature there, migrate secondary, right? So we can do it ourselves if automatically it does not move. And what we can see from here is that the hypervisor 2 is up, but no, it does not move that. So what we can do is we can just move the secondary. If we right click on the secondary, does it, and go to fault tolerance, does it have any option? No. If we right click on the primary and go to fault tolerance, it says migrate secondary, right? So in this situation, we can use this option, and it's going to migrate its secondary to the other hypervisor. Right now it's on 3. It's not supposed to be on 3, so I'm just going to go for change compute resource only. And that option is only available on primary machine. And it's telling to move it to ESXi2 because ESXi3 now has the new primary. And from the primary, we have the option of migrating the secondary to any other hypervisor. So yep, we're migrating. We're asking it to migrate to, yep, it's gone. And so on 3 now there is only primary, and if we go to 2, now it has a secondary. So we could have moved any one of those, but this is it, that you have, after the disaster strikes and the only second hypervisor that we have comes up, then we can just move secondary. Hence that right click. Before I was right clicking going to fault tolerance, I was saying, hey, there's this feature. Now we get to know that why this feature is there. In case of disaster of just the 2 hypervisors, if one goes down, then the 2 machines, primary, secondary, will actually be on the same hypervisor. Then you have to move the secondary to a different hypervisor. So that option is there. Okay, so that's the fault tolerance, and it works with we have 3 screenshots. So the next topic would be vSAN. That's a big one. And we would actually be installing another hypervisor in next class, which is the 14th. And then the 15th class will be the final quiz, right? And so yeah, we're going to be then going for vSAN lab next class. Okay, so I'm just going to suspend the machines. You can upload the screenshots as soon as I create that. Suspend. Suspend it. Okay. Okay, I'll create that folder.